Okay, good morning again. I saw lots of, like almost all of you took the quiz, which is great. Only two of you didn't take the quiz, most probably you forgot or something. Uh, from next week, you can do that. You got my reminder email yesterday, all of you? Okay, great. So that is working. So you will have this sort of reading quiz every beginning of every week. I hope that will help. You can tell after today's class if you feel a little bit more comfortable with the topics or not, because you already know a little bit of at least some terms or something. Hopefully that will help. So for today's class, learning, I made a little bit aggressive objective, but we shouldn't start number 3. So we will start with number 1 and number 2, and number 3 is for the next class. So let's start working on that. What we will do, we will define and we'll try to understand some very basic fluid properties like density, specific weight, something like that. Okay? So let's start working on that. Now, the very first and very important property of fluid is density. What is density? What do you think? Mass divided by volume, okay, that is the equation. So what does that mean, mass divided by volume? What does that mean? Concentration of mass anywhere, or it's mass divided by volume. So concentration of mass within the starting volume. Yes. So if you can measure the volume within a certain unit, when we say certain, you always want to use the unit, right? The lowest unit. It can be 1 cubic feet, it can be 1 cubic meter, it can be 1 cubic inch or something like that. If we can find that, like what is the total amount or total mass of the matter within that unit volume, that is actually the density. Or in other words, how dense the matter is within a certain volume, right? So if I want to define that, it will be the mass of the fluid that is contained in a unit of volume, because we always want to know within unit so that we can find the other numbers. Just think about that. If you know the unit price of banana, you know what will be 1 dozen of banana, right? What is the cost of that? Exactly like that. If you know the unit, the mass of unit volume, if you have the volume of like 1,000 times greater than the unit one, you already know what will be the density, like the total mass or something, right? Okay. Now, what symbol we use for density? Gamma is for something else, which we will cover in next slide. Yes, rho is the symbol we use for density. And you already told me the formula or equation, which is mass over volume. Are you seeing a small line with the V? Maybe you already know that. Again, just to explain, the V is, we usually use V for velocity and volume both. Just to avoid any confusion, we will always use V with that line to represent the volume, so that we don't get confused with the velocity. Okay. Now, since we know the equation, can you tell me what will be the unit or units for density? Will we have multiple units or just only one fixed unit for density? What do you think? Why you should have multiple units? I think the correct exact answer should be, since we are using multiple unit systems, right? We are already using 2 different unit systems. One is FPS, one is for SI. And at the same time, we can express the density in terms of meter cube, in terms of centimeter cube, in terms of millimeter cube. So there can be multiple units, but as a starting point, I will limit my units into 2 standard units. One is for SI, one is for FPS. So for SI unit, what do you think? What will be the unit for density in SI unit system? Kilogram over meters cube. Okay, because kilogram is the unit for mass. Now, for FPS system, what will be the unit? Great. This is the first time someone said slug per feet cube at the very first chance. In my two other classes, they said that pound over feet cube, but we already know that slug is the unit of mass in FPS unit, right? Okay, great. So kg per meter cube or slugs per feet cube are the unit for density. Those are the standard unit. But for any reason we need to convert anything, we can always convert the unit from meter cube to centimeter cube, millimeter cube, kilometer cube, anything. As long as we make the necessary conversion. Okay. Now, for density, for fluid, we know there are two types of, like we can divide fluid into two different parts. One is liquid, one is gas. Now, it's good to know some standard values. So for liquid, what standard liquid we use like most frequently? Water. And for gas, which gas we use most frequently? For gas, we are surrounded by what type of gas? It's not exactly oxygen, it's a mixture of oxygen, nitrogen, also some other gas, but there's a common name, which is air. Yes. So we are surrounded by air. That's why it's good to know what is the density of liquid or air at the standard density of something. So for water, it's 1000 kg per meter cube or 1.94 slugs per feet cube. From that, can you see the very last line? If you have difficulties, you can log in into Zoom from Canvas, from your fluid mechanics Canvas page. Maybe that will be a little bit easier for you. You can see the screen on your computer. Okay. Now, I didn't add anything for air. That's because air is a compressible or incompressible fluid. Compressible? Okay. So compressible means you can change the volume, right? That's the meaning of compressible, like compressible. That is the meaning of compressible. You can change, you are able to change the volume or compress the volume. Now, for air, since it's compressible, whenever we say the density, we need to specify the pressure and temperature also. That's why even if we don't remember the standard value, that is okay. You can always go to appendix A and find the exact density for air at specific temperature and pressure. Okay, but it's always good to remember the water density because it's more or less same. Okay. Okay, so as we just discussed, for gas, temperature and pressure, that is very important. And because of the compressibility, that is important. For liquid, pressure is not that much important because, as we said, it is incompressible. You can't compress too much. But for temperature, there is a change. Because for temperature, the volume can increase a little bit. So you will see with one example how that is changed. So for example, for water at 4 degrees centigrade, density is what? 1000 kg per meter cube, right? And at 100 degrees centigrade, the density is what? 958.1 kg per meter cube. You see, for 96 degrees centigrade change, the density didn't change that much. A fraction of that. So you can see what will be the effect of temperature and density, liquid density. But at the same time, if you look at the air density, the density of air at 15 degrees centigrade and atmospheric pressure 101.3 kilopascal, it was 1.23. Now with same temperature but changing pressure, it can be doubled, 2.46 kg per meter cube. Because when you apply more pressure, the volume is what? If you apply pressure, volume is what? Increasing or decreasing? Decreasing, but the total amount of air is same, right? So mass is same, but the volume is decreasing. As a result, density, they are more dense within that space. So the density is increased. Okay? And from your appendix A, you will see with different temperature, different pressure, the density can be changed. Now, even if the air or any gas is incompressible, if the range of temperature is small, the density can be assumed constant and they can be considered incompressible. But that is a very special case, and unless I state something like that, we will always consider gas as what? Compressible or incompressible? The gas, compressible, and the liquid, incompressible. Okay? Are we good up to this point? Are you done with this slide? Okay. So I'm changing the slide. Now the next important one is specific weight. What is specific weight? There is another name of specific weight, which is unit weight. So from the name unit weight, can you define the specific weight? Unit weight. So you have unit volume. And if you know the what? You are not concentrating. From the name unit weight, you know it's unit, so it's unit volume. And how can you, what is the equation? At least can you tell me that? Specific weight. Weight over volume. So what does that mean? The weight of the matter dense within 1 unit of volume. Yes. If you have a box of 1 meter cube or 1 feet cube, if you can find the volume of, sorry, weight of that box, that is actually the specific weight, right? Weight of the fluid that is contained in a unit of volume. Okay, that is the definition. Now, what symbol we usually use for specific weight? Previously, we used rho, now gamma, exactly. And the equation we just discussed, that will be weight over volume. Now, do you remember we made the connection between mass and weight in our last class? What is the relation between mass and weight? Like how can we connect mass and weight? Just by using gravity, exactly. Just like that, we can connect specific gravity and density as well. So what I will do, I will work with this equation, how we can make the connection between gamma and density. So for W, can we write down this way? Mass times gravity. Can we or we can't? Okay. Now can we rearrange the equation in such way that mass times mass over volume times gravity? The same thing I just rearrange a little bit. Now mass over volume. What is the name of that? Mass over volume. That is density. So density times gravity. And again, the relation between density and specific weight, it's only gravity. So if you know the density, you can use, you can find the specific weight and vice versa. Now, what will be the unit in SI system and FPS system? What is the unit of force in SI system? Newtons. And what is the unit of volume? So it should be newtons per. What will be the unit? Newtons per meter cube, yes, or pound per feet cube, right? Okay. Now, once we know the density and specific weight, we will start the next one, which is specific gravity. Do you have any idea about specific gravity? You have the idea, you just can't remember right now. Oh, and the specific weight of water is 9810 kg. Okay, I made the wrong unit here. That should be Newton per meter cube and feet, a pound per feet cube, not kg or slugs. Those are the units for mass. So that should be Newton per meter cube and pound per feet cube. Okay. Okay. Now the next one is specific gravity, and another name of the specific gravity is relative density. So whenever we say relative, what does that mean? Relative means what? There will be some sort of reference, right? And with respect to that reference, we will measure something that is the relative. Now, specific gravity is actually the density or unit weight of some liquid or gas with respect to some standard liquid or gas. Now, what is the standard standard liquid we will use here or we should use here? Water. And what is the standard gas we should use here? Air. That's what we will do. So, the definition is ratio of the density or specific weight to that of another substance that taken as a standard. Now, the symbol for specific gravity in your textbook, they use S, but in some other textbook, they use SG, specific gravity. So sometimes I will use S or SG, but they will mean the same thing. And the symbol is S or SG. And the formula should be something like that. Okay? Now, are you seeing that SL, the subscript here? SL here. SL is like the substance, liquid here, substance, liquid. And the W is actually what? Water. Okay. Here, SG. So S is the substance, which is gas. And A is what? A stands for what? Yeah, air. Yes. Now, can you tell me what will be the unit? Now, if you do like, there is an easy way to find units. If you don't use that, you can use that way. So always start from the formula or equation and find the individual unit, and then you can work on that. So what are you seeing? It's the same quantity on top and bottom. So the unit should be same and they will cancel each other. So finally, what we will have as a unit? Unitless, nothing. So there will be nothing. And that's the beauty of specific gravity, that you don't have to think, whoa, I'm using SI system or FPS system. That doesn't matter. It will be always same, the specific gravity, which is unitless. Now, if I ask you one tricky question, what is the specific gravity of water? One. What is the specific gravity of air within certain temperature and pressure? Because we are measuring that within the same thing, which is one. Now, for oil, they usually float on the water, right? That's because they are less denser than the water, right? Same thing we will, like, you can actually use that. Now, if you use a brick particle, do you think it will float or it will like drown in the water. A brick particle maybe. What these one? Do you think it will float on the water? This marker? Most probably no, because its unit weight or density which is higher than the water. That's why it sink in the water, right? Okay, so main thing is specific gravity will give you some sort of idea how dense or how, sorry, like how light or how heavy one substance is with respect to water, something like that. Okay. Okay. Are we good up to this point? We got the basic idea of density, unit weight, and everything. Okay. If we know this, let's work on one past example, how to find something from some known value. This is class example 2. All of you should have one blank copy of that. I will work on this problem on the board. Okay. So let's work on that. By the time I go to board, can anyone read the question loudly so that everyone can hear?
Tanker conveys 900 times barrels of crude oil. Considering the weight of the oil, the gravity is 49 to the barrel contains 40 gallons in there.
Thank you very much. So we are saying there's a tank which is filled with a number of barrels, and each barrel is filled with a number of gallons of some sort of oil, right? And they are asking to find what is the total weight of all of this fluid. So let's work on that. So what we will do, and this I will practice this standard all the time whenever I do any class example or homework or anything. At first, I will write down what are the given values. Okay. And then I will write down what the unknown to find. And then I will try to make unknown and known values into some known. Okay. And that is a standard practice. That's how you solve a problem. So, can you tell me what is the first given value you can see in this question? Volume of what? Yeah, so number of it is 900 10 to the power 3. What else? What else is given?
Specific
Specific gravity of what? Okay, sometimes maybe I can just say, okay, crude oil, you need to find out the specific gravity from this or something. But for this question, they already gave you, which is 0.94, and you can see there is no unit here. What else we know? Okay, so each barrel contains 42 gallons. So I will write down number of gallons. We have that number of barrels and each one contains 42. So what will be the total number? 42 multiplied with that one, right? What else we know? We also know, or they already gave you, like one, how can you connect the gallon into 50? Okay, so we said that 152 equals to 7.48 gallons. So those are the given values. What we have to find we need to find?
The weight,
Weight of what?
that weight,
Yeah, weight of the crude oil, right? That's what we need to find. Now, you are already expert of density, specific gravity, and everything. Can you direct me? How can I find the weight of the oil based on the given data? What should be the steps or what should be the approach to solve this problem? How can I get the weight from the given data? Let me help you a little bit. There is a relation between specific gravity and weight of substance. How can we start working on this problem? Specific gravity means what? We just covered that. So specific gravity means what? Or another thing. Okay, I will let you find out how to start working on this problem. What are the given values and we need to find a weight. What should be the weight? Okay, so if we need to find weight, right? W. Do we know gamma equals to like what? W over volume, right? Now we don't know the gamma oil, but we know something about the oil, which is specific gravity. Is there any way you can connect gamma oil to the specific gravity? How can you find that? I will name that as equation 1 maybe. Now, specific gravity of oil equals to gamma oil over what? Gamma. What is the standard of liquid? Water, right? Equals to 0.94. Gamma oil equals to 0.94. Can you tell me what will be the gamma W? Before doing that, what unit system we are using? FPS or SI? FPS. Okay, you need to be louder. I can't hear you properly. It's FPS, right? Now tell me, what is the unit weight of water or specific weight of water in FPS unit? You have that in your class lecture. Go to the specific weight part and tell me 62.4. And what is the unit? Pounds per feet cube. Good. Now give me that number. What is that number? Bring calculator in every class. We will do practice problem on every day. Okay, what number you got? 58.65, and the unit should be same, right? Now you can see we know the gamma oil And we can connect that to here, right? Okay, let's do that. So from equation 1, from that, can you read my handwriting on the board? The last row? Okay. So W equals to 58.65 lb feet cube. What is the total volume? What is the best way to find the volume? We know the number of gallons, right? What is that? This one, 42. So 42. Now look at this one. We have the volume in feet cube here. We have the volume in gallon here. So I can't work with two different units in one single problem. I need to convert that either from feet cube to gallon, or I can convert the gallon into feet cube, and that's why they gave you this conversion time. Okay? So how can I convert? I will convert this one. 1 feet cube equals to 7.48 gallon. Now I can cancel gallon, feet cube. Ultimately, what do I have? Give me that number, proper. What will be that? You should get a very big number. It starts with 2. Do you get any number? Okay. 200. Tell me with 10 to the power something number. After 296, how many digits do you have? Okay, anyone else got something like that? Maybe 29.6 10 to the power 7, something like that? You need to say yes if you get that. Okay, last 2 rows. Anyone got that number? 296 something? Okay. So it's 296 10 to the power 6. What is the unit? The weight SPS system. So pounds, right? So that is the total weight of all the barrels that tanker is carrying. FPS system. Okay. So here it was a good practice so that you can connect how can, if you know the density or specific weight, how can you find something else? At the end of this week, maybe Friday or end of Wednesday class, we may go to lab and we will try to calculate the density and specific weight of the water. And just to check that if we can get realistic number from the actual test. Okay. Okay. Are you good up to this point? Okay, we still have 15 minutes. I think I can start the, oh, I still have to cover one more properties, which is bulk modulus. And from your solid mechanics, I already know, you know that. Do you remember the term modulus of elasticity or bulk modulus of elasticity from your solid mechanics class? It's exactly the same thing. We will cover that here also for fluid. Now, any one of you can remember the basic of that one? Like what was that representing, that modulus of elasticity? Anyone can remember anything about that one? Or it's like how much resistance an object can offer to the applied pressure, right? So if our object can resist too much of too much pressure, their modulus of elasticity will be higher, right? And so what do you think for solids, liquid, and gas? Which one will have the higher modulus, bulk modulus? Like for solid, you can apply some force, it will resist almost all the force, or it will check, it will not be able to resist anything. What do you think? Okay, this is the mouse, right? Will I be able to change anything too much here? Because it can resist the pressure, right? But if I take some hand sanitizer and I do that, it will go all over my hand, right? Because it can't resist that much. That's why you will see the solid materials, they have very high bulk modulus, and the gas has the lowest one. Okay? So if I want to define that, it will be the measure of the amount by which a fluid offers a resistance to compression. Okay? And if this black line, this one, that was the original box or volume, if you apply some force, it will be compressed, and this ash color box, that is the final volume. And obviously, based on this one, you can identify what amount of force they could resist, right? If it can resist too much, obviously there will be not that much change. If it can't resist, it will be distorted, right? Okay. So that's what we will see. Now the symbol, most of you can remember that it's EV. Sometimes we say that just E. When you will do, have you taken structural theory, like where you need to design the beam, column? Did you see that EV on that, like the steel? You will see at some point, like you need to know what is the bulk modulus of the steel or something like that. Okay. Now the equation here, dP is the differential pressure or the change in pressure. dV is the change in volume with respect to unit volume. Are you seeing a negative sign here? What does that mean? Whenever you have negative sign here, that means the relation between the top one and the bottom one is just opposite. It's just the more pressure you apply, it will be, the volume will be decreased in that scale, right? So minus sign indicates that increase in pressure causes a decrease in volume. Just like a straight line equation with a negative slope. Okay. This is a straight, you can actually make that a straight line equation here. Now, what will be the units? What do you think? We didn't discuss the pressure yet, so maybe you don't remember the unit for pressure. In SI system, the unit for pressure is Pascal, and for FPS unit, it's pound per square inch or square feet, something like that. So, can you tell me what will be the unit for this one? We have volume over volume, so that cancel each other, right? So basically, we'll have the unit for pressure only, right? Okay, now pound per square inch, that is not a standard unit, but we use that a lot. When you, can you open the door, please? When you check the pressure on your car tire, which, what do you say? Something PSI, right? So PSI is P pound, S like pound per square, I per inch square. So pound per square inch, okay? So though it's not a standard one, but we use that a lot. So when we do some calculation, we need to make sure that we convert that into feet. We will do that, don't worry. Okay. Now some examples here. As we said, for solid, it will be very high. For steel, it's 160 gigapascal. Now liquid, This is for example at the deepest point of Pacific Ocean. So there, the differential pressure can get 110 megapascal, and for that one, the bulk modulus can be 2.2 gigapascal. Okay, and for gas, it's very low. However, for if the gas flows at low velocities, then only change in pressure, only small change in pressure will occur. So even a low bulk modulus at a constant temperature, a gas can be incompressible. Again, it's just special case, and unless I state something, you will always consider gas as compressible, liquid as incompressible. Okay, good. Do you have any question up to this point? Anything? Good. I think I was still good explaining everything. That's why you don't have any questions. I should feel proud, right? Okay, I'm proud. Okay, so the next one. I'm 100% sure you know the ideal gas law. In your high school chemistry, do you remember the equation PV equals to nRT? Everyone? That is actually the ideal gas law. Now PV equals to nRT. N is some sort of like, it depends on total number of molecules and everything. Here, since we work with fluid, we will try to use a different form of that equation where we will work with density. So we will just modify that, not modify, we'll come up with different expression, and that's what I will do on the board. Before doing that, we need to define what is ideal gas. The true thing is there is nothing called ideal. It's just we assume something for simplicity. So the ideal gas is, since it is gas, when gas molecules don't have any attraction to each other, that's when it's called the ideal gas. So the molecules are spread far enough that they don't have any attraction to each other. Okay, and using this gas, like using this equation or ideal gas law, we can express the behavior of ideal gas, and that's why it's called ideal gas law. So the behavior of ideal gas is described by ideal gas law. And I will start from the form you already know, and I will derive the form which we will use for this course. Okay? And then we'll be done. I will be able to complete that. If I can't, that is fine also. Next class. Do you remember Avogadro's number? Some sort. We will not use that, just so in your first year chemistry, what you usually cover? This chemistry period, what is the content of that? You took some chemistry courses here, right? What is the content of that? I never checked. You don't know or you don't remember? Remember. Good. That is the current one. Okay, ideal gas law. So, ideal gas law from high school chemistry. You know that PV nRT. And you already know the name of most of the quantities here. P is what? Pressure. Yes. And it's a very specific type of pressure which is called absolute. We haven't discussed the pressure, absolute variable pressure yet. We will do that in next class. For now, just remember it's the absolute pressure. V is what? Volume. Yes. Okay. T is what? It's gas. So temperature is very, very important. Now again, it's a very specific type of temperature, which is absolute. Do you remember what was the absolute temperature? If we measure the temperature from negative 460 Fahrenheit 4, right? At that point, molecules can't move, that is absolute zero temperature. So that is the absolute temperature. M is should be gas constant or air. Okay, it's for air, standard gas. And M is actually amount of substance. So amount of substance means I will write down the second line and together. So basically this one is PV M R heat. So this M is mass and this one is molar mass. So molar mass means the mass of the total Avogadro number, and for each type of gas, obviously the particle will be different. So that is the mass of that particle. Okay. Now let's rearrange a little bit. We have volume, we have mass. Is there any way, instead of using two different quantities, can we come up with one single quantity, which is very important for me, and it is related to mass and volume? What quantity we can use? Density, exactly. Because density is related to mass and density, volume, right? Okay, so I will just arrange this equation a little bit. I move that volume here and that way. So P M over V is what? Rho. R over M is another constant, R, without any bar on top, and T. That is the ideal gas law expression we will use. I will name that R. This is called ideal gas constant. Can you go to your appendix A and find the R values for different gases? Can you verify that you have that on your appendix A copy? Do you have that? For this, oh, I don't have any appendix with me. Here, go to this one and you will see just the fourth table from like 1, 2, 3, 4 here. Are you seeing that R values here? And for different scale, we will have different R values also. So we'll start from this point, okay? In our next class. If you have any questions, stop by in the evening. Okay? Do you think your quiz was a little bit helpful for today's class? Do you remember anything from your reading material? Okay. Okay, good. I'll see you on Wednesday. Thank you very much.
how you doing?